So here we have the 2017 paper 2 question 1 on probability. When Connor rings Kira's house, the probability that Kira answers the phone is 1/5. So Connor rings Kira's house every day for 7 consecutive days. Find the probability that she answers the phone on the 2nd, 4th and 6th days, but not on the other days. So if the probability that Kira answers the phone, let's call it P. So I'll just get it black. So the probability that she answers the phone is 1/5. And I'm going to say that I'm going to call the probability that she doesn't answer the phone Q. So if the total probability scale is from 0 to 1, the probability that she doesn't answer is going to be 1 minus 1/5. So it's going to be 4/5. So that's the probability that she doesn't answer the phone. So I'm looking for the chances that she will answer the phone on the 2nd, 4th and 6th days. So if she's answering on the 2nd, so we have the 1st day, 2nd, 3rd, 4th, 5th, 6th, and 7th. So she's going to answer it on the 2nd, so we're going to have the probability that she answers here, so it's going to be 1/5, and she answers on the 4th, so under the 4th we'll have 1/5, and she also answers on the probability that she answers on the 6th day. But then if we're only going by the probability that she answers on these days, we're going to have the probability that she doesn't answer on the other days, so it's 4/5, 4/5, 4/5 and 4/5, and we're going to multiply these together to get the total probability all together. So if we multiply these together, we shall get an answer. Just can do it on your calculator, 1 second. So it's going to be 4/5 by 1 over, you can do 4/5. Or if we wanted to maybe, because we have 4/5, 1 4/5, 2 4/5, 3 4/5, we have 5 4/5, so 4/5 to the power of 5, and then we have 1, 2, 3, 1/5, and then 1/5 to the power of 2, 3, sorry, we have 4 4/5s, and then we have 3 1/5s. So then if we just multiply, if I just plug that into my calculator, so 4/5 by 4, and then 1/5 by to the power of 3, and I got an answer of 2, 5, 6, 7, 8, 1, 2, 5, or if I wanted to convert it to a decimal, it would be 0.0032768. So that's the first part of that question. And then we'll go on to the second part. So I'll just get the second part. So the second part says, find the probability that she will answer the phone for the 4th time on the 7th day. So we're looking for the probability that she's going to answer the phone, probability, I'm just going to repeat for probability, that she answers phone for the 4th time, on the 7th day. So that's the probability that I'm after, the probability that she's going to answer for the 4th time on the 7th day. So if I'm just going to write this, so 1, 2, 3, 4, 5, 6, 7. So on the 7th day, we're going to say that she's answering for the 4th time. So if we remember back to our probabilities, the probability that she answers is 1/5. So then the probability that she doesn't answer is going to be 4/5, because the total probability will have to equal 1. So we're going to have the probability that she answers for the 4th time on the 7th day. So on day number 7, we're going to have a probability of 1/5 that she answers. But here we have 6 days, and we want to say that she answers the phone 6 days. And so if she's answering for the 4th time on day 7, in these 6 days she's after answering 3 times. But she could have answered on the first, the second, the third, or she could have answered on different combinations of days. So we're going to have to multiply our factor. We're going to have to multiply the probabilities by a number, which is going to be, we're going to have, how many spaces do we have to fill? So we have to fill 6. And the thing that we're looking for, we want her to answer 3 times. So it's going to be 6, choose 3, multiplied by the probability that she answers, which is 1 over 5. And there's going to be 3 of them. And then the not answering is going to occupy the remaining spaces. So it's going to be 4 over 5, 3. Because in those 6 days, she's going to answer 3 times and she's not going to answer the other 3 times. So that's the probability that she answers 3 times on the 6th day, in 6 days. But then we're going to have to multiply the probability that she just answers on the 7th day. So it's by 1 over 5. So then that's going to be 6, choose 3. So then we have 1 over 5 cubed by another 1 over 5. So it's 1 over 5 to the power of 4, and then 4 over 5 to the power of 3. So I'm just going to get that on my calculator. So 6, choose 3, and then that's 20 multiplied by 1 over 5 to the power of 4, multiplied by 4 over 5 to the power of 3, and I get an answer of 2, 5, 6, 1, 5, 6, 2, 5. Or if I want to convert that to a decimal, they accept both answers, so it's 0.016384. 0.016384. So that's the probability that she answers for the 4th time on the 7th day. So I'm just going to check. So there's one last part of that question, and it says Connor rings her house every day. So Connor rings every day for n days. So they haven't told us how many days. So he rings every day. So once every day for n days. Right, in terms of n, the probability, so probability in terms of n, that she will answer the phone. She will answer the phone at least once. So we're going to say that she answers that at least once. So there's going to be at least one time that she answers the phone. So we weren't told exactly how many days he's ringing for. So the probability that she answers the phone at least once could be the probability that she answers the phone once. She could be twice. She could answer it once. She could answer it twice. She could answer it 3 times. She could answer it 4 times, all the way up to she could answer it just one less than the total amount of times, which will be n minus 1, all the way up to n. So the probability that she will answer the phone at least once includes a lot of probabilities. But, so it's very difficult to calculate the probability that she'll get it once, twice, 3 times, 4 times, all the way up to this n that we don't know. But the probability that she doesn't answer the phone at all, we can calculate that. So it's going to be, the probability that she doesn't answer the phone any day, so it will just be 4 over 5 by the number of days. So say if she doesn't answer the phone for 2 days, the probability will be 4 over 5 plus 4 over 5, because that's the probability that she doesn't answer the phone. But so the probability that so say for 2 days, that's the probability that she doesn't answer the phone, it's going to be 4 over 5 squared. The probability that she doesn't answer the phone for 3 days will be 4 over 5 by 4 over 5 by 4 over 5. And I think you can see where I'm going with this. So that'll be 4 over 5 cubed. The probability that she doesn't answer the phone for 4 days will be 4 over 5 to the power of 4. So the probability that she doesn't answer the phone for any of those n days is going to be 4 over 5 to the power of n. But we want the probability that she answers the phone at least once. So if this is the probability that she doesn't answer the phone at all, 1 minus this probability is going to be the probability that she answers the phone at least once. So that is our answer for that. And I'm just going to get our next question. And then find the next part of this question is find the minimum value for n So find the minimum value for n or of n for which the probability, so how many days does he have to ring, that the probability that Kira will answer at least once is greater than 99%. So we're looking for find the minimum value for n, so find the least amount of days for which the probability that Kira will answer the phone at least once is greater than 99%. So the probability that Kira answers the phone at least once for n days, which we're just after working out, I'll just change my pen color, is 1 minus 4 over 5 to the power of n. If we want the probability that she answers, so this is the probability that she answers at least once. So we want to figure out a value for n for which this will be greater than 0.99. I'm just after converting 99% to a decimal. So if I want to get, I'm going to have this on one side, so I'm going to put this to the other side. So it'll be minus 4 over 5n is going to be, so it's going to be 0.99 minus 1. So that's going to be, so it's going to be minus 4 over 5 n is greater than minus 0.01. But I have a minus here, so if I multiply both sides by a minus, I'll change the direction of the inequality just to get rid of my minuses. So 4 over 5 n is going to be less than 0.01. So if I wanted to, I'm looking to get a value for n. So say if I wanted to let my n, so say if I wanted to get a value for n, if I wanted to solve this, so for just let 4 over 5 to the power of n equal 0.01, and then I can have it for as log of 4 over 5, 0.01, and n will be, I'll just get my value for n, so log, so we have log 4 over 5, 0.01, and then we get a value that n is equal to 20.637. So when she answers the phone, so when the probability that she answers the phone at least once is, so if the probability that she answers the phone at least once is 99%, she's going to have to, is exactly 99%, he's going to have to ring 20.637 days. But we want to get the probability that it's going to be greater than the day that it's going to be, the day that the probability that she answers the phone will be greater than 99%. So the day that will just be great. So this is on the 20.637 day, it will be 99%. So on the 21st day will be the first day that it will be greater than 99%. And that is our answer for that. I'll just check that we've finished the question there. So I think that is us. That's our question finished. Thank you.